This question is about how to maximize the profits for a company. This company estimates that it can sell 5,000 units each month when the price is equal to $75. And when they decrease the price for 25 cents, then the sales will increase by 20 more units. And the company has the fixed cost for $50. And the cost to make each unit is $4.90. We want to find the level of the production to maximize the profits. So we want to maximize the profits, and so we have to get the equation or the function for the profits. Recall that the profits is equal to the revenue function minus the cost function. Let's find the revenue and the cost function so that we can do the subtraction. Okay, we can do the cost functions very easy. It says right here we have the fixed cost of $450. So $450 is a constant, and then the cost to make each unit is $4.90. That is the slope of the cost function, $4.90, and let's act to be the amount of the number of the units. Okay, so 4.90 multiplied by x, because 4.90 is the amount for each unit. So we multiply by the number of the unit x, and we add to the fixed cost of 450. So it's easy to get the equation for the cost, but now we have to find the equation for the revenue. Okay, let's look at the original problem. It says right here, when we have 5,000 units, then the price is equal to $75. So 5,000 units, then the price is $75. This is the first point that we have. This is the number of the unit x, and this is the price. Okay, and now every time that you decrease the price by 25 cents, so let's say the first time that I decrease the price by 25 cents, so I would have $74.75, right? You take $75, you minus 0.25, you get $74.75. Then you get another extra 20 more units from 5,000. That is 5,020, right? That is the first point you get. And then you get another, let's say you are decreasing another 25 cents. So 74.75, when you subtract another 25 cents, that would be $74.50. And therefore you get another 20 more units, which is 5,040. And note that here, the changing of the price is 25 cents. Okay, so you take the initial, the final value, which is this one, right? You subtract the initial value, 74.50 minus 74.75, and then divide by. Actually, we'll just take the delta P, right? That is the change from the new to the old price. So that should be minus 20.25. So because the new value is always 0.25 less than the old value, so we take the new value minus the old value. So the delta P, the change in the price, should be negative 25 cents. And we also want to find the change of the delta X, right? That would be the difference between any two values. So that would be 5,000, the new value minus the old value, and that should give you 20. And that is the difference between any time that you increase or decrease the price by 25 cents. Okay, now we can find the slope of this, right? The slope is simply just the change of the price divided by the change of the units. So that is minus 25 divided by 20. So minus 0.25 divided by 20. And that should give me negative 0.0125. And the reason that I want to find the slope, because I want to get the equation. Okay, let's just say I have let's just say I label let's just pick the first point. Okay, x1 y1. Okay, now we want to find a linear equation, so we will find y used up y minus y1 equal m x minus x1, the point slope formula, right? And we have y1, which is 75, and we have the m is the slope. The slope, we just got it here, minus 0.0125, and x minus x1. x1 is 5,000. And now I'm trying to solve for y. So I multiply by 0.0125 multiplied by x, and then negative multiplied to negative will be positive. And when you multiply minus 0.0125 multiplied by 5,000, you get plus 62.5. And then I have y minus 75. And therefore, I can solve for y by adding 75 to both sides. And when I do that, I get minus 0.0125x and plus 137.5. Now, if you look back to our problem, the x value in this case is x, right? It's the unit. So it will stay at the unit. The y value in this case is the price. So we are now just replace the y by the price, just so we can apply that to our problem. Okay, we use x and y just to make it easy, so that we can apply what we learned from algebra to get the equation. But after that, we'll change the equation to p and x. In this case, p is the price and x is the number of the amount of the unit. Okay, the amount of unit. Okay, now we got the equation for the cost, and I have to find the equations for revenue. And all I just did here, they will help me to find the revenue, because the revenue by itself is equal what? The revenue is equal the price multiplied the quantity. Okay, the price in this case is the P. The quantity, the number of the units, which is X, right? But then we have the equation for the price, which is this one right here. So I'm replacing the P by minus 0.0125x plus 137.5, and I multiply by x, the number of the quantity, right? The x right here. And then now let me just complete this equation. So it's minus 0.0125x squared, and then multiply in here, I'll get plus 137.5x. So this is my revenue equation. Okay, so I have my revenue equation. I have my cost equation. I'm ready to find my profit equation. That is what I need to find. So profit is equal to revenue minus the cost. And the revenue is the equation we just got down here. So let's just rewrite that. 137.5x. And now we minus the cost function, which is 4.90x plus 450. 4.90x plus 450. Okay, and let's just simplify this further. Minus 4.90x minus and plus become minus 4.450, and plus 137.5x, and then bring down, and this entire equation is the profit equation, right? Okay, and then I can combine these two. 137.5 minus 4.90 that is 132.6x. Again, remember x is the amount of the unit, okay, the quantity, and this is the, again, the profit equation. Okay, you want to maximize the profits. This is the max-min problem. To maximize the profits, we need to find the critical value of that, right? So first thing, we have to find the derivative of this profit equation. So bring down the 2, minus 0.0 minus 0.0125 multiplied by 2, that is negative 0.025, and then subtract 1 to the exponent, you get 1. And then the derivative of 132.6x, it's just 132.x, the slope, and this is a constant, it's become 0. And then you set the derivative to be 0, and you can add 0.025x to both sides, 0.025x to both sides, and then now you can divide by 0.025. Okay, so 132.6 divided by 0.025, that will give me x to be 5,304. And this is the only critical value, right? And usually it should be the amount that maximizes the profits. We can also use the second derivative to check for that, right? To find the second derivative, we will take another derivative of this guy. So this guy becomes minus 0.025. No more x because this is number 1, so bring it down, subtract 1 to that. This is a constant, it becomes 0. So the second derivative is negative. It's less than 0. Then it's always concave down for the entire domain. And because this is concave down, you are expecting to get the maximum value at the critical value. Okay? So the x equals 5,304. That is the value. Remember, the x is the quantity, okay? The quantity. So this amount of unit, 5,304, this should be the value that maximize the profits. And look at the answer, 5,304 units. They should produce this many units, okay? Now we want to find at what price. Well, to find the price, we have to go back to the price equation. The price equation is right here, okay? This equation, the price. This is the equation for the price. And now you just have to plug in. This value right here, the x value of 5,304. So I take minus 0.0125, multiply 5,304, and I add to 127.5, right? You just make the substitution and then add them to get the price. And it should give you 71, if you do it correctly, 71.2. That is the price to maximize the profits. And that is right here, 71.2. And finally, they want you to find what is that profit. Okay? So again, you go back to the profit equation, which is this equation right here. This equation is the profit equation. So now, anywhere I see x right here, I am making the substitution of 5,304. So I take this one right here, 5,304 square, multiply negative 0.0125, and then I add to 132.6, multiply 5,304 x, and then I subtract 450. And my value that I get should be, the profit should be 351,205.2. So $351,000, 205, and then 0.2, which is this one right here. All right. So that is how you solve this question, how to maximize the profits. And first, we need to come up with the revenue and the cost functions. from the given problems here, and then subtract them and take the derivative, set it equal to 0, and then solve for x, and then find the second derivative to make sure this is the maximum value, and then go back to the price equation, find that particular price, and then go back to the profit equation to actually find that profit at that maximum value.